time for us to move on to 5.2. Still talking about triangles, some other concepts of triangles. This is inequalities in triangles. And while most of you understand what an inequality is, I think it's important that we get a definition down that we can work with some couple of examples. Definition of inequality. Okay? Formal definition we're going to use is for any real numbers a and b. Algebraic expression a and b. For any real numbers a and b. A is greater than b if and only if there is a positive number c such that a equals b plus c. Read it again. For any real numbers a and b, a is greater than b if and only if there is a positive number c such that a equals b plus c. An example, if 6 equals 4 plus 2, then 6 is greater than 4 and 6 is also greater than 2. Okay? Alright? 6 would represent, let's write this down, the a. This would be your b, and this would be your c. Okay? So if a is greater than b, then there has to be a real positive number c that exists so that a equals b plus c. Okay? And then of course a is going to be greater than either one of those. Formal definition of inequality that we're going to be using to look at. Very simple. It would also be good for us to review the algebraic properties, basic algebraic properties of inequalities. They're very simple. Inequalities basically say that we can compare numbers, values, three different ways. Comparison property, we can compare a to b and find that a is less than b. We can compare a to b and find that a is equal to b, or we can compare a to b and find that a is greater than b. The way I remember this is the big side on the big side, little side on the little side. Whichever one is little on the little side. This is little, so this is little. This is big, so this is big. A less than b. Oh, there's no big or little, so this is equal. Oh, A is on the big side of this map, B is on the small side, so therefore A is greater than B. Simple. Transitive properties of inequalities. If A is less than B and B is less than C, then A is less than C. Also, if A is greater than B and B is greater than C, then A is greater than C. Transitive property of inequalities. It's like the transitive property of equalities. Also, the addition and subtraction properties hold. If A is greater than B, then A plus C is greater than B plus C. All we're doing is adding a constant to both sides. We add the same thing to both sides. We have not changed the inequality values or the relationships. And A minus C is greater than B minus C. Nor have we changed the value, the inequality values, when we subtract a constant from both sides. Same thing, if A is less than B, then A plus C is less than B plus C, and A minus C is less than B plus C. So, simply by adding or subtracting a constant from both of those numbers does not change the value of the inequality. This is still going to be less than this, and this is still going to be less than this. Basic properties, algebraic properties of inequalities need to review. Last properties, algebraic properties of inequalities we need to review are the multiplication and division properties. These are things you already know and you've been using, have used in Algebra 1, Algebra 2, other math courses. If C is greater than 0 and A is less than B, then A times C is less than B times C. So if C is positive, then the inequality valuation of A to B is going to remain the same if we multiply or divide by C. If C is positive, A is less than B, then AC is less than BC, and A divided by C is less than B divided by C. Again, if A is greater than B, then AC is greater than BC, and A divided by C is greater than B divided by C. Okay? That's if C is positive. What happens if C is negative? If A is less than B, then we reverse this. Notice these are reversed. If C is less than 0, then AC is greater than BC, and A divided by C is greater than B divided by C. In other words, we reverse the valuation of A and B if C is less than 0. Same thing down here. If A is greater than B and C is less than 0, then we reverse that valuation, and A times C is less than B times C, and A divided by C is less than B times C. Now notice that there is no equality property for C equals 0 for multiplication and division. Why? We multiply 0 by A and 0 by B. We just get A, 0 is greater than or 0 is less than 0. Can't make that happen. And we have no idea what division by 0 is. That number is totally undefined, just like slope is. Why? Because the slope of a perpendicular or a vertical line is undefined. We don't know what it is. Because you've got division by 0, there's no run. Okay? Other properties that you need to review about inequalities before we go forward on talking about triangles. Okay, now let's take these inequality properties into triangles and let's talk about those. Setup here is basically, we're going to look at exterior angles of a triangle and look at a term called the exterior angle inequality. Now, we can come in here and say the EAT, eat states, no, it's not time to go eat, but the exterior angle theorem states that measure of angle 4 equals the sum of angle 1 and the sum of angle 2, measure of angle 2. Okay, angle 1 and angle 2 are the remote interior angles of angle 4. Exterior angle equals the sum of its remote interior angles. That's what the exterior angle theorem says. Now, what we call the exterior angle inequality theorem states that because of this, wow, and the definition, and when it works, and the definition of inequality, that measure of angle 4 has to be greater than measure of angle 1, and it also has to be greater than the measure of angle 2. If you can add two things together to equal a third thing, then the third thing has to be greater than either one of the individual first two things. Okay? Stands to reason. It's just the definition of inequality. Go back and look at your definition of inequality. Okay? If this represents A, this represents B, and this is C, we have a definition of inequality. If there is an A greater than B, that can only happen if we can add a C to B that will equal A. Okay, and in this case we've done that. We have an A, it's the measure of angle 4, and we have a B, which is measure of angle 1, and we have a C, which is measure of angle 2. So A is greater than B because we can add something to B to equal C. Okay? Add two things together, come up with a third, then the third is greater than either one of the two things we added together. That's all this is saying. This angle is going to be bigger than this two. Okay? Bigger than these two. Okay? Let's do some example of it.